Assalamu alaikum, brothers and sisters. Welcome to the journey of Quest, where we quench your thirst of knowledge. Ever pondered why our Earth remains neither bone-chilling cold nor scalding hot? This intriguing phenomenon is due to a scientific marvel known as the radiation balance. So, let's dive into understanding this concept. Picture an enchanting dance of energy, a detailed choreography playing above us in the boundless theater of the universe. Our glorious planet, Earth, basks in the hue of the sun, immersing itself in its fierce light and heat. Visualize the energy from the sun in the form of animations of waves of light and heat beaming down upon Earth. This energy, which we receive copiously, doesn't just evade into oblivion. It plays a significant part in influencing the Earth's atmosphere and is instrumental in maintaining the temperature crucial for the continuity and evolution of life as we understand it. Imagine Earth as a giant energy sponge, continuously primed to soak up. It absorbs an impressive quantity of solar radiation. The Earth's surface, oceans, and atmosphere all act as sponges, soaking up the solar energy. Now visualize animations of these areas absorbing the solar energy, the photons penetrating the atmosphere and the heat spreading across the lands and oceans. However, just like a thoroughly squeezed sponge, Earth doesn't monopolize all the energy for itself. Picture an animation where Earth radiates some of this absorbed energy back into the cosmos as long-wave radiation, or as it's commonly known, heat. As the Earth's surface drinks in short-wave energy in the form of sunlight, it warms up. As Earth heats from absorbing the sun's energy, visualize it releasing this heat as long-wave radiation. This radiation is then expelled back into the cosmic vastness, yet some of it is soaked up by specific gases in the Earth's atmosphere, which in turn re-emits the energy in all directions. This process constitutes the natural greenhouse effect, which is indispensable for terrestrial life. The equilibrium between the absorbed solar radiation and the emitted long-wave radiation is what we call the radiation balance. Visualize this delicate balance as a seesaw in animation. On one end, we have incoming solar radiation, and on the other, outgoing long-wave radiation. This equilibrium is intricate and delicate, and when these two forces are in harmony, our Earth's temperature remains relatively constant. Hence, our Earth is neither excessively hot nor cold, making it just right for life to thrive. When these two forces are in sync, Earth's temperature remains relatively stable. Now let's delve deeper into the radiation balance. It's not a fixed entity. Rather, it is a dynamic process that's constantly in flux, persistently altering and adapting with respect to various factors. This concept, to put it simply, is the balance between the incoming radiation from the sun and outgoing radiation from the Earth. It's a crucial cog in the machine that keeps Earth's climate and climate change in check. Imagine the Earth, with its broad expanse not as a monotonous sphere, but as a vibrant canvas painted with a myriad of different terrains and geographical features. Each of these features, be it the expansive deep blue oceans, the dense green forests, or the vast arid deserts, has its unique characteristics, and each one of these regions plays a significant part in the radiation balance in its own unique way. They absorb and emit radiation, but the rates at which these occur are notably different. Picture this: the oceans, with their dark surfaces, soak up more radiation, like a sponge absorbing water. Now imagine the Arctic regions, their white snowy surfaces reflecting more radiation, much like a mirror bouncing off light. Animations illustrate these disparities in absorption and emission rates among different regions, showing how they have a substantial impact on the overall radiation balance. This vast array of variations across land and sea weaves an intricate web of energy exchanges that delicately balance our atmosphere. But the Earth's surface isn't the only player in this game. The atmospheric constituents, including greenhouse gases, also wield influence over the radiation balance. Picture gases like carbon dioxide, methane, nitrous, and others as dancers in this energy ballet. They absorb some of the outgoing long-wave radiation from the Earth that would otherwise escape into the vastness of space. This absorption results in trapping some of this heat radiation, which is then re-emitted back towards the Earth's surface. Visualize the greenhouse effect, as animations demonstrate vital player in the radiation balance game. This effect not only helps stabilize Earth's temperature, but it also wraps our planet in a warm blanket that sustains life. This precarious balance of radiation, despite its ever-evolving nature, is a key contributor to the planet's habitability. Without it, and the dynamic variables influencing it, life on Earth as we know it would not be possible. Remember the greenhouse effect, as it plays a vital role in the radiation balance, keeping our planet at just the right temperature to support life. To delve a little deeper, the radiation balance, in essence, is an intricate equilibrium, a delicate ballet between the energy Earth receives from the sun and the energy it radiates back into space. It's not merely a straightforward operation, but a complex, meticulously coordinated energy exchange that unfolds on an astronomical scale. Our primary source of energy, the sun, dispatches waves of heat and light towards our planet. This radiant energy traverses the infinite cosmos, overcoming hurdles and enduring the austere interstellar conditions in an unyielding quest to reach Earth. This incoming energy, also known as solar insolation, forms the principal input in this delicate energy balance. Upon reaching Earth, the planet's surface and an atmosphere come into play. They receive this energy, a fraction of which is absorbed, thus warming the surface and the lower strata of the atmosphere. The remaining energy is reflected back into outer space, a phenomenon known as albedo. This absorption and reflection are influenced by numerous factors, including the characteristics of the Earth's surface, be it a barren desert, a frosty peak, or a verdant forest. The composition of our atmosphere also significantly influences the radiation balance. Certain constituents of the atmosphere, namely greenhouse gases, ensnare a portion of this energy, stopping it from escaping back into space. This phenomenon is what we refer to as the greenhouse effect, a natural process that warms the Earth to a degree that can support life. However, this equilibrium is not unchanging. It's a dynamic, perpetually shifting system that can be influenced by a myriad of factors. Changes in the sun's energy output, alterations in the Earth's orbit, volcanic eruptions injecting particles into the atmosphere, human activities producing an excess of greenhouse gases, all these have the potential to disrupt this delicate balance. The versatility of the radiation balance is what makes our planet livable. It prevents our world from transforming into a perishing, frozen desert or a blistering, uninhabitable wilderness. It regulates the planet's temperature, ensuring it is just right for life to evolve and flourish. In summary, the radiation balance is a cosmic ballet, an energy pendulum that maintains our planet's temperature. It's a fragile performance where every element, every process, every interaction plays a critical role. Our world's splendor, the variety of life it nurtures, the climates we experience, all hinge on this equilibrium. In this celestial ballet, every step, every move is of paramount importance. Now let's use animations to illustrate this cosmic dance. Each step will be precisely depicted to emphasize the importance of every process in maintaining this delicate equilibrium. Observe as energy from the sun travels across space, interacts with our planet's surface and atmosphere, and is either absorbed or reflected back. Notice the role of greenhouse gases and how human activities can tip this balance. This is not just a dance, it is a symphony of processes that keeps our planet habitable. Thanks for watching. Take care of yourself and your family, and do subscribe our channel.